All right, so this next block, what we want to do is talk about a couple things. Typecasting. I'm going to give you an example of what typecasting is and why you would need it. And then we'll import a couple libraries to just show you sort of the standard that we're going to use. And then one of those libraries that we're going to import is called Sympy. And we'll just work through an example. And you can see what we're going to use. Everyone's seen the kinematic equations before. We're just going to use the kinematic equations and derivatives and show you that Python can actually do the same kind of operations that Mathematica does. So I'm just going to show you an example just using the derivative, and maybe we'll solve something as well. And then we'll do that. Okay, so typecasting is the act of changing a variable from one type to another. And you might not realize it, but you're going to need to be able to do that at some point. Here, let me restart the kernel just to get us a fresh set of Python code here. So we got nothing going on, nothing in the variable explorer. And all I'm going to do, so you haven't seen this before, but input just allows the user to input something into. So what we'll do is we'll run this, and then we'll come back down here and we'll have to input some information in, right? So it's asking the user to import or to give it a number. All right, so down here, and you can see in our comments that we want to add two numbers together from the user input. So I want to take the number 1 and I'm going to add it to number 2, and hopefully we get 3. And the problem is we didn't get 3. So think about real quick what actually happened and what we're going to need to do in order to change that, right? So if you look down here, I told it to print out num1 plus num2, and what in the heck just went on? Well, I don't know. Maybe you didn't get it. So do it again. You can give it 2 other numbers. What happens when I give it a 3 and a 4? I'm expecting 7, but I got 34. So I got problems. So how can we go about fixing it? I'll let you think about it for a second. So up here, you'll see that num1 is of type string, and it's a 3, right? And you can also tell by the colors. So we'll see here in a second when I change this when I typecast into an actual integer or a float, depending on sort of what we decide to do, that this will change, the color will change, right? So get used to seeing like this little pinkish color is for strings and other colors for numbers. Okay, so we understand that what this thing did was it just took the 3 and the plus operator on 2 strings just concatenates them together without a space. And so that's all it's doing. In order to change it, what we're going to have to do is a couple of different things. You could, in other words, I could type in int right here, int right there to typecast it, but I'm going to just do it at the bottom just for readability's sake. So num1 is equal to int num1, and then num2 is equal to int num2. And let's run it again. So now if I press 1, 2, hopefully it gives us 3. Okay, so now it gives us 3, and you can see that the pink color changed because now it's an integer. It changed to 1 plus 2 is 3. So is that what we wanted to do? I don't know. If we're trying to add 2 numbers together, well, let's see what happens if we do something a little different. So it worked for 1 and 2, but I would tell you that the most difficult thing that you're going to have to do when you're programming is make sure that it answers all the questions. So let's see if this answers all the questions. And I'm not sure if maybe it will. 2.5 and 3.4. Let's see what happens. Oh, so that's not good, right? So it's telling you that, hey man, you tried to turn this into an integer, but it didn't like it. So what's another thing that I can do here? Well, integer is one of them, but I can also do a float. That's actually not what I expected to happen, but that's fine. I expected it to give us sort of some kind of rounding errors. 3.5, 2.4, we get 5.9. Now, is that 5.9? I don't know. 5. Okay, yeah, so 5.9. And if I wanted that to be an integer, then I could then turn around and say, num12 is equal to integer of num1 plus num2. And then let's print off that thing. Now, are we doing exactly what it says up here? No, I'm just sort of experimenting with this thing and just showing you what it can do or what it's doing. So we'll do 3.5 and 2.4 again, and 5 this time. And so what happened was it took that 5.9 right here where it says num1 plus num2 should have been 5.9, and then it turned it into an integer. So all it did was, if you've ever heard of the floor operator, it just basically chopped off all of the digits after the integer, right? So it just said, okay, at 5.9, so the first integer up to that point is a 5, right? So it just gets rid of all of the decimal places. All right, so that's the typecasting example of why you would need typecasting, and that's how you do it. So if I want to typecast something, I just basically take the variable and tell it what type I want it to be. In this case, we want it to be float. So I took the num1, which was a string, and I said, hey, turn that string into a float. And then that's what num1 came out of. And you can see num1 is a float, num12 is an integer, and all of these are light blue. All right, the next thing we want to talk about was Sympy. So let's go back to OneNote and then bring up this. Let me grab it. Put it on the side, and then put OneNote on the other side. Okay, so importing libraries. So as you can see, I'm importing Sympy as SN. This is the way that we want to import libraries in our code in this class. The reason why we want to do that is because if you just hit import Sympy, then it's going to write over any other version of, maybe you have a square root function, maybe you have something that Sympy has in its library, and it's going to overwrite, and that's not what I want to do. I want to be able to use the stuff that's in Sympy just by using SYM, and you can import math as M, right? So m dot square root now, m dot exp. You can import, I think we used SciPy already, SciPy as SP standard. So this is a very standard one that people use, SP. Later on we'll do NumPy. You can import NumPy. So import NumPy as NP. Now you're not authorized to use any of these until we get into block 2. So, but I wanted to at least introduce you and talk about our standard of pulling libraries into Python. This is how we're going to do it. And now you get this thing that says, hey, you've imported, but you didn't use it. You imported it, but you didn't use it, so on and so forth. So we can get rid of these. Control Z. I'm probably gonna use math here in a second. All right. So we've imported Sympy, and now the first thing you're gonna do in Sympy is I'm gonna say T. I'm gonna specify. So I'm gonna let these all be sim dot symbols. All right, so symbols is a function, method I should say, or it's a function. It's a function inside there, and we're gonna let it be T, V0, and G. So anywhere, oops, not a comma. So we're gonna let those be symbols. All right, now I'm going to define this equation. So y is equal to V0 times T. So what it's doing is it's treating this V0 as a symbol, and it's treating T as a symbol. And then minus, so all I'm doing now is I'm just copying this equation here, this V0 times T minus 1/2 G T squared. So minus, with 1/2 times G times T. Remember, squared is the double multiply, right? So star star. Then if I want to take the derivative of it, so if I wanted to take dy dt, again, you can go and find out all Sympy's functions that they have in there. I'm just giving you an example of how you can do this. It's going to be sim.diff is how you're going to take the derivative. Then you simply just put in the y, because that's the function how I defined. And this function, so this function actually had the symbols in it that we're worried about. So that's why you can do y, and you can tell it to take the derivative with respect of, in this case is t, f9. F9 here, so f9, f9. And then let's just print dy dt. and you'll see that it's the derivative, right? So the derivative should have been v naught, which is v0, minus g times t, right? So we know that's the derivative, and then Python gives you a way to do that. What if I wanted to take second derivative, right? So what if I wanted to, down here you see that the second derivative of y is just negative g. So let's do that one. Let's just print, I won't even sim dot diff, I believe, and then you put y in, and then I'm going to take two derivatives. So I'm going to take it with respect to t. So that comes out to, and then you get negative g. So you get what we expect over here, so negative g. And now what I want to do is, right now we haven't defined a function that I can start substituting things in for. In other words, I can't do y of 1 and get out what happens at time equals 1. You have to do this extra little step here, and I'm going to call this function r, right? So I got r of t. So now what I'm going to do is I'm going to take this y thing that we've already defined in terms of things that had symbols in it, and I'm going to turn it into a function that I can use and substitute in different values for v0, t, and g. So r is equal to sim dot, it's called lambdify. It comes up, and then all you do is you pass in the variables t, v0, and g, and you say, you get to give it the function. So here what I did was, so y was this function that had just v0, t, and g in it. So that's that guy. And then these are the variables that I want to define. You could have done this just by putting t in and putting values in for v0, but we'll just let this be the most general case. And then F9. And now what I can do is start printing out, okay, so with t 0.1 and v0 is equal to 10, and g we know is 9.8 because we're going to use meters per second squared, and hit F9. Hit 9.51, and that makes sense because of the equation, right? So r is let's put in a couple more in. Yeah, I guess we could graph it, but we really haven't talked about how to graph it yet. So it's going up. Negative something. How about 6? We want it to maybe 3. We're just playing with this thing. 1.9. All right, so somewhere after, we can solve this thing too. I mean, there's a way to solve this. Use this function and solve for when t's equal to 0. And that's certainly a way, or something that we can come back and solve. Okay, so suppose we wanted a function for the velocity. Maybe v is equal to sim dot lambdify. I guess this one's really not helpful. But another thing that we can solve is sim dot solve. So what this does is it solves when this function with respect to t is equal to 0. So what it does is it takes that as a symbol, v naught as a symbol, g as a symbol, and then it solves for these other ones in order to figure out when they're equal to 0. So you get an F9. And you get 0, obviously, because if you put t is equal to 0, these two go to, so then y, your function y will be 0. And then if you put this in for t, you would also get, so this would probably tell us what the value was that I was sort of searching for. v0 is 10 divided by 9.8, so whatever that is probably the t that we would put in order to find the other 0. All right, and so say we had a, I don't know, another one. Remember, t is currently a variable, so I can put it in like this. So t squared plus 2 times t minus 15. before I solve for that, let's figure out what that sucker is. So t squared plus 2t minus 15, that is t, I have a plus, so it's 5, right? So it must be a plus 5 and a minus 3. So we think t should be a minus 5 and a positive 3. All right, let's find out what Python tells us. Minus 5 and plus 3. Okay, so you can see the benefits, hopefully, of doing that. All right, the last thing that we want to talk about is this idea of documenting your code. So using these things in order to be able to, the things that are available to you. So to put in comments, right? So I've put in a comment here. You can see there's other ways of doing it with the 3 quotation marks. Just know that that is out there for you to document the code. And you're not talking to just yourself, but you're also talking to other people who are going to read your code. You want your code to be, and you're talking to your future self. I mean, that's one of the things that Hadley Wickham said when he came in, is it's a good thing to document, because you might really get into this and know what's going on, but really what you want to do is to be talking to your future self. And your future self isn't as smart as the current self, right? So that's the thing. But this is how I would do it. I'd come on here and say turn into symbols. Lets me know the purpose of this line of code is to let's see, y is equal to, so turn it into a function. So use the symbols in a function. So use the symbols in a function. Derivative. So if you come back and you're looking for real quick, hey, how did I take the derivative? There it is. Yeah, I don't care about the print. Turns the function to an evaluate that. In fact, I'm going to just take this. I'm going to use the 3. Looks like it was sort of getting out of the way. Turns the function into y. That's what we'll do. We'll say turns y into a function that is equal comma b0 comma g. And again, you can just keep typing in stuff into here to make sure that you really understand what's going on in that next little piece there. And then solves equation. So that's what it did for t. Solves equations t when y equals 0. How about that? In the same thing. Okay. So what is the purpose of documenting or commenting your code? It's really, really good to do so that you can remember what you were doing, right? So that's the idea, right? If you can just give yourself a quick, oh, it turns into symbol. Okay, so that's how I do that. Use the symbols in a function. Oh, okay, this turns that sucker into a function. So if you're able to do that and just recall real quickly what's going on, it would be very helpful for you in the future. All right, that's all I got for you. Have a great day.